physicists in this physics conference with my little laser and my little string, trying to explain to them that a wave is a 3D vortex. And some physicist that come from Canada saw me doing that, and he had brought this device that he thought was a cool toy. And when he saw me do that, he said, "You need this device," and he gave it to me. So since then I present with this, which is much better than my little razor string. Okay, so I'm going to try to do this in a way so I can build. Can you pull on that string above your head? There you go. Appreciate. So here, I orbited the string, and as soon as I put it together, this is what happened. The string self-organized into a vortex, but the vortex was quantized. Can everybody see the two-dimensional waveform here? The 2D sine wave? Okay, well, the 2D sine wave is a 3D vortex, right? We all agree, right? And when it does go into self-organization, it generates very specific quantas. Can everybody see this? These quantas are the particle, and this is the wave. You see? The wave and the particle come together naturally when you have a 3D vortex. You all see what I mean? All of a sudden, it's not either a wave or a particle, it's both in the same dynamic. The particle and the wave.
Now, when you disrupt that, it'll balance itself back out, right?
Pardon me?
When you disrupt it, it'll balance itself right back out, just like this.
Yeah, you can disrupt it, and you see, you can change the amplitude, but you can get like stable,
Chaotic contractor.
yeah, stable standing waves, like this one. And they're very beautiful as well. They generate really interesting fractal structures in between them, if you can see in the middle there.
Are those available to purchase?
I wish. I've never been able to find another one of these, and I looked hard and long. And you can continue to create. See, this is. Let me see. This is a 2 frequency, right? So again, self-organized. Does that look like anything? Right. Now I had a contact for the petals, or for the lobes in between the intersecting spheres. The spheres are the radiating side of the event horizon. Those radiating spheres intersect, creating standing waves. That is the electromagnetic field. You see that? And so that you can actually make this the 1 frequency. Let me see if I can get. Let me spin it up. This is one of the interference patterns.
Now, a wave of water in the ocean coming onto a beach, is the water molecules coming in a spiral?
That's right. The water molecules are moving through the wave. You know, like surfers going through the tunnel? The water molecules are going through the wave like this along the shore. And the wave appears to be moving this way towards the shore. But it's actually a vortex. So, let me see. You can get, let me see if I can get it. Oh, way up. There we go. Here you get a tetrahedral array of waveforms in the middle. Oh, I lost it. Oh, sorry. It's kind of hard to show to a large audience. Need a camera on it. In any case, you can get all the interference pattern you need, including the wave and the particles together, all in one. You don't have to have some weird dichotomy between the two. And if you actually can get some really cool stuff. At slow speed. Here's the interference patterns at slow speed. Isn't this neat?
If you leave it long enough, does it always naturally organize itself, or is it organizing because you're moving it a little bit?
It's organizing because I'm moving it. If I change the wave frequency, right, there's places where the distance, due to the length of the string, will create interference, like here. But then if I change that length, when it's at the right length, then it will self-organize. And when it does, the rate of rotations of the motor changes. You see? And so it has to do with the wavelength and the speed of rotation. So here is my string theory. And so it became obvious that the wave and the particle are unified when you allow the spherical coordinates of the 3D vortex dynamic to be involved. Go ahead.
That relationship between the frequency and the
amplitude?
perhaps it's escaping me a bit, but is that the same dynamic as on the graph before between the frequency and the radius? I mean, is there
Yes.
Is there a correlation there?
There's a correlation, absolutely, because it's the radius and the frequency will dictate the resonance of the system, will dictate the fundamental resonance of a system. So it's either in constructive or destructive resonance, and if you change the length of the string, you either get constructive waveform or destructive waveform, and the two generate, you know, the dynamics of the expansion and the contraction and so on. So yeah, it is definitely related. The radius of a system and its angular momentum are directly related, and its energy output, the surface of the system and the amount of information moving through it is directly related. So it all works together. You're right. So I guess I was really, I was amazed about that, because but then I was thinking, okay, you guys, this is where you guys gonna have to do some nonlinear thinking, because I was thinking, all right, now if you have a planet moving around the sun, right? But then the sun is moving around the galaxy. That's a larger spiral, because the galaxy is moving through space. And then the galaxy is orbiting a cluster of galaxies. That's moving through space. And then that cluster is orbiting a larger cluster, which is orbiting the universe, which is a larger spiral, and that universe is orbiting a multiverse, a larger universe, and a larger universe, and a larger universe.